Okay guys, lesson 4. This is page 14 in your unit packet. I'm actually going to skip page 14 and I'll explain why. So we're going to skip that right now and I'll explain why. I actually am going to post the notes from page 14, but here's the idea. Everything here is about inverse trig functions. So the derivatives we need to know. If you have inverse sine, then the derivative 1 over the square root of 1 minus u squared du dx. That's the formula you need to memorize. And now there's 5 others you have to memorize. Cosine inverse. Well, that's just negative 1 over square root 1 minus u squared du dx. Same formula. Cosine has a negative 1 on top. Now we need tangent. And the derivative, 1 over 1 plus u squared du dx. And we need inverse of cotangent, which is negative 1 over 1 plus u squared du dx. And finally, secant inverse. The derivative is 1 over u square root u squared minus 1 du dx. And I'm guessing you will know what cosecant inverse will be. Negative 1 over u square root u squared minus 1 du dx. So these are the 6 inverse trig derivatives that you need to memorize. Yeah, it's 6. I count it as 3 because if you know the 3 for sine, tangent, and secant, then all of the co-functions just have a negative 1 on top. So that shouldn't be too bad, hopefully. Now, page 14 is what I skipped. What page 14 is all about. And again, I'm going to post my notes to it, so if you want to look at it, you can. Feel free, and if you want me to go over it with you, I'm happy to. But what page 14 is telling you, how do you get from inverse sine to this random formula over here? Page 14 shows you why the derivative of this is that. What you need to know for the AP test are these formulas. So I'm kind of just going to skip ahead to what you need to know. If you're confused as to why that's happening, I'm happy to go over that with anybody. What all of these formulas are, if you'll notice, all of these are inverse trig functions of u, and then that's why du dx is on the back of all of these, because that's your chain rule. Whatever the value of u is, you have to take the derivative of that. And I'll show you some examples. Okay? So for every question, this is the way I set it up. It's inverse sine, so I know I need to use my formula. So whatever you're taking inverse sine of, that's the value of u. So in this case, u equals 2x. Well, if you look at your formula, you need to use a u squared. Well, that's 4x squared. I also need du dx. So what's the derivative of u? 2. So now I can just substitute everything I need into my derivative. Y prime equals 1 over the square root of 1 minus, the formula says u squared, so I'm going to fill in 4x squared, chain rule, times du dx. Well, what is du dx? 2. And you're done. And of course, just like we've done in the past with other questions, you can put the 2 on top. And that would be fine as well. Okay? So if you look at the next one, inverse cosecant of all of this. So that means that u is the 3 radical x. Okay. Well, if you look at cosecant, I need the value of u, and I need u squared. Hey, Joey. So I'm going to take this right here. Yeah. U squared, 3 radical x squared. So what does that turn into? 9x. Now I also need du dx, which is the derivative of this. Well, the derivative of radical x, or excuse me, you have a coefficient, so that stays there, times the derivative of radical x, 1 over 2 radical x. Okay, so now I have everything I need for my derivative. Y prime equals negative 1 on top because it's cosecant over the value of u, square root of u squared, so that's where I fill in the 9x minus 1 times du dx. So I'm just going to rewrite that as 3 over 2 radical x. And you're done. Question 3. I'm taking inverse tangent of secant x. So secant x is my u, which means u squared is secant squared x. Okay. And what's the derivative of secant? Secant x tan x. So now I'm just going to follow my formula and get my answer. Y prime equals, for tangent, it's 1 over 1 plus u squared. Well, that's this. Times du dx. That's all of this. Now remember, I could put times secant x tan x right over here on the side, or I can just put it right on top of my fraction. So if you look at this, what if I just take that away? Du dx, if I'm multiplying by du dx, I can just stick that right on top. Secant x tan x. There you go. Okay. Last one. Now remember, arc cosine is the same thing as inverse cosine. Okay, it's the exact same thing, just they do different notation. So what are you taking arc cosine of? 5x to the third. Okay, well, I need u squared for my formula, so I'm going to take this value right here and square it. So that's going to give me 25x to the 6th. I also need the derivative, which would be 15x squared. Now I can take my u squared and du dx and substitute them into my formula for the derivative. The derivative is negative 1, I'm leaving that blank right now, over the square root of 1 minus u squared times du dx. Well, that du dx, I could put it off to the side, or I could just stick it right on top. And of course, I have that negative there because it's cosine. Any cofunction has a negative on top. And those are your inverse trig derivatives.